Hey everybody, and welcome back to another fun and exciting Algebra 1 class. Today we will be finishing chapter number 8, and this is on page 265 in your book. Page 265, we have been dealing with radicals and how to add them, reduce them, multiply them, and so makes sense that we would be finishing up here with how to divide them. So here's some kind of key things in this lesson. One of the big things is we have to understand what's called the quotient rule for radicals. Here's the quotient rule for radicals. And that is when you have a fraction under a radical sign, it is the same as having a radical over another radical. Okay, what do I mean by that? Well, let's take a look over here. So if I have, don't pay any attention to this right now, okay? I will get to that in just a second. And of course, I say don't pay any attention to it, and what are you going to do? You're going to pay attention to it, but stop paying attention to that, okay? So pay attention to this. What I mean is if you have something like this where you have a fraction under the radical sign, it's the same thing as writing it like this, the square root of 9 over the square root of 64. It's the exact same thing, okay? So get used to that. Get used to taking it from this form to this form. This is the first step in solving these. So use the quotient form of the radical to take it from basically a fractional radical to a radical over another radical. All right, now let's pay attention to this. To rationalize the denominator, and you might be thinking, well, why would I want to rationalize the denominator? What does that mean? In math, there's certain things that you can do and can't do. One of those you can't do is this is not a good answer in math. This needs to be rationalized, okay? What does that mean? We need to get rid of this radical sign, okay? Now, in this one, this is a really easy one because this obviously solves out. So what is the square root of 9? That comes out to 3. What is the square root of 64? That comes out to 8. Your answer is 3 over 8. This one automatically rationalizes, okay? But what happens when that doesn't happen? What happens when you get something like this one down here where you have square root of 3 over the square root of 10? The square root of 3 doesn't rationalize, and the square root of 10 doesn't rationalize. So now what do we have? What do we do? Well, check this out. To rationalize a denominator, multiply both the numerator and the denominator by the denominator. It's like, whoa, what? When I show it to you, I think it's going to make a lot more sense. So what is the denominator? The denominator is the square root of 10. It says to multiply the numerator by the square root of 10 and the denominator by the square root of 10. And this is going to be like a fraction. Now, let me show you why, all right? I just want to take a second to show you why. Whenever we're multiplying, we can always, if I had 7 times 1, what does that equal? Well, 7 times 1 always equals 7. This is identity. 7 times 1 always equals itself. It always equals identity, right? And that should make you smile. All right, now, you're like, Mr. Steve, come on, seriously. Okay, I tried to make you smile. It's algebra class. I tried to do things that make you laugh. Okay, didn't work. Okay, sorry. I'll try harder next time. All right, so what we want to do is, because of this is a principle that you need to understand. If I multiply 7 times 7 over 7, that is actually going to equal what? It's going to equal 7, because 7 over 7 equals what? It equals 1. Because if you divide 7 into 7, you get 1. So this is an identity. When you're multiplying by the fraction that is the same, it's identity. And so if we do this, this is how this would work. And we'll get 1, and then that one doesn't cancel. And so we get 1 times 7, 7 over 1, which obviously equals 7. So we ended up back to where we were. This same principle right here, the same principle right here is going to work right here with this. Why? Because we're actually multiplying by the number 1. And you're like, that is the weirdest looking number 1 that I've ever seen. Well, remember in identity, whenever you have a fraction, the same numerator and the same denominator, it always equals 1. So the square root of 10 over the square root of 10 equals 1. Okay, we are multiplying this by the number 1. Now, it's a tricky way to multiply by the number 1, but we are multiplying by the number 1, and that's really, really important to remember as we're doing this. All right, so what's this going to look like? Well, here's what's going to happen. So this is where the magic takes place, and this is where we rationalize the denominator. So multiply this out, and we get what? We get the square root of 30, and that is over 10 times 10 is the square root of 100. Okay, now this solves out to what? This solves out to 10. Now our new denominator is 10, and we get the square root of 30 on top. Now, you might think, we're done, good, circle it, okay, bingo. Well, not quite. So what we want to do real quick is we want to test this, and we want to see, is this solved all the way out? Can we solve it any farther? So what does that mean? Well, this is where our square factors come in. So 4, and then 3 times 3 is 9, and then 4 times 4 is 16, and then we don't have to go any farther, but we want to see if the square root of 30 can be reduced. Okay, and so we're going to try different numbers to see. So we're going to say, can 4 go into 30? No, 4 doesn't go into 30. Can 9 go into 30? No, it cannot. Can 16 go into 30? No, it can't. And so because we're over halfway to 30, so in other words, the only thing that could be divided by would be 2. 25 is the next one, and that obviously doesn't go into 30. We don't have to go any farther. And so nothing goes into that. So in this case, we are finished. Not all the time will you be finished. Sometimes you will have to reduce that out, but this time we don't have to. All right, so now let's do this one here. Remember, the first thing that we want to do is we want to go ahead and divide this out using the quotient rule and make these separate problems. The next thing we want to do is we want to multiply by 1, okay? In this case, what is the 1 that we want to multiply? Well, we take the denominator and we multiply by the numerator and the denominator. In other words, it's the same thing. It's an identity. We multiply by the number 1. You say, again, this is the strangest looking number 1 I've ever seen. That's okay. You're just going to have to get used to it and deal with it. That's the way that you're going to get the correct answer on these. Here we have x squared times y squared. You could actually solve this out if you wanted to right here before. This will just be less complicated if we solve this out and then just the x comes out, because remember the index is 2, so these match, so it comes out to an x. So we have x times y square root of y is going to give us x square root of y over, and what happens here is technically we get the square root of y squared, but the square root of y squared is just y. So you don't have to write that. You can actually just take what's underneath it, and that's what comes out. You're rationalizing the denominator, okay? That would be your correct answer. Again, you would check and make sure that you can't take anything out of the numerator, which we actually did. We took it out over here, but we did get something that could be taken out, so we took it out. We reduce it as far as we can reduce it. All right. Next thing and last concept for this chapter. To rationalize a denominator of a binomial, multiply both the numerator and the denominator by the conjugate of the denominator. All right, so when you see this right here, you see this radical in the denominator. You can't just solve it by saying, oh, I'm just going to multiply both things by the square root of 2. That's not going to solve this right here, because when you try to do that, you're going to end up with 4 square root of 2. So you still have a square root in your denominator. So that's not going to work. So go back up to this and let's look at this. To rationalize a denominator of a binomial, what we want to do is multiply both the numerator and the denominator, so kind of the same process, by the conjugate of the denominator. What's that? It's the same thing except for we're going to put a plus sign here. So we're going to multiply this times 4 plus the square root of 2, and we're going to multiply this times 4 plus the square root of 2. This is, again, the weirdest looking number 1 that you've ever seen, but this is an identity thing, and this is all we're doing is rationalizing the denominator, or we're putting it into the proper format, okay? So up here, I'm just going to distribute that, and I'm going to get 12, and then plus 3 square root of 2. In the denominator, it's going to get a little bit crazier because I am actually going to do FOIL. So I'm going to do firsts, and that's going to give me 16. And then I'm going to do the outers, all right? And that's going to give me a plus 4 square root of 2. And then I'm going to do the inners, and that's going to give me a minus 4 square root of 2. And then I'm going to do the last. So that's going to give me a negative square root of 4 minus the square root of 4. Okay, and so we'll extend this. Now what we want to do, I'll do it underneath, is we want to go ahead and we want to basically just, this is going to stay the same. 12 plus 3 square root of 2, because we can't do anything there. We can't solve anything. We can't reduce anything. This 2 is already as small as it will go. But this one, we can do some things, okay? So let's look at what we can do here. We can say 16 plus minus. Plus minus, what does that mean? Oh, it was a conjugate. Oh yeah, that's right. That's always going to cancel. Notice that our square roots, our roots here, they cancel out. And then notice here that we get a perfect root. So we have a minus, and then we have a perfect root, the number 2. So now we'll rewrite this and we'll solve this out just a little bit better. And that's going to look like 12 plus 3 square root of 2. And that's going to be 16 minus 2, which is 14. And that is going to be our answer. We would circle that, okay? All right, let's do one more, and then we will be done with this chapter. All right, so here we go. We're going to take this dude right here, and we are going to multiply by its conjugate. So square root of 6 minus 2 and square root of 6 minus 2. And you're like, oh my goodness, we got to FOIL both of them this time. Yes, I know. Isn't this terrible? All right. So again, we're going to do the same thing. We're going to do first, outer, inner, last. So first, I'll change the color so we don't get too confused here. And so we're going to get, again, going with the first, and we're going to get the square root of 36. Square root 36. And then outers is going to give us minus 2 square root of 6. Inners is going to give us minus 3 square root of 6. And then the outers is going to give us a positive 6. Okay, and that's all going to be over this right here. So first is going to give us square root of 36. The inners, or the outers, is going to give us minus 2 square root of 6. The inners is always going to give us the opposite, which is plus 2 square root of 6. And then the last is going to give us a negative 4, minus 4. And then again, we'll just do the same thing. We'll combine like terms. And so our like terms and things that we can do, look, we can combine this. We can solve this thing out right here. So what is the square root of 36? It's 6. And then notice what happens here. We have minus minus, so we're going to get a minus 5 square roots of 6. And then we have a plus 6. We could solve this even farther, but we'll wait for just a second to do that. Let's go ahead and solve this. That comes out, and it's another 6. And then this, remember when we're doing the conjugate, that's always going to cancel that middle term. And then we had a minus 4. So now we just need to clean this up and we need to do the math that's involved there. And so what are we going to get? We're going to get a 6 plus 6. That's going to be a 12 minus 5 square root of 6 over 6 minus 4 is 2. And that would be your final answer. Now, some students want to do this, so be careful that you don't do this. Some students want to reduce this, and they're like, "Oh, I have a 6 minus 5." No, 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 no. Because, and I'll tell you why, because this is all part of the same thing up here. In other words, we would have to factor something out of this in order to cancel that. You remember that from binomials and with the letters, right? So when we had the letters, we couldn't cancel that, and we can't cancel again when we have these radicals. So we just would leave that alone, and we would circle that answer, and that would be our final answer, and we'll just leave it alone right there. That's all I've got for you. If you missed something, which you probably did, that was quite a bit going on there. Make sure to slide that back, watch it again, slow it down if you have to, and take your time, practice some of these, and I think you'll get it if you keep working at it. All right, that's all I've got for you. We'll see you later. Have a good one. Bye bye.